Welcome to the third session of the data science practice sessions. And this week we are going to now import the data into Python and explore the data. We'll keep it short and sweet, do some descriptive analytics on top of it, do some documentations, and next week we'll go to the next step according to the CRISP DM process. So, hey guys, in case you're new to this place, I'm on a mission to help data science aspirants, working professionals, non-coders, and students get a job internship in data science by 2025. And I know data science takes a lot of practice, and so I'm here every week for another 10 sessions for this one cycle to get complete to help you set up a solid practice session. Quick short note. We are working on the CRISP DM process. We do business understanding of the project. Then now we're going to do data understanding, import it and do all of these steps in this particular session. And so, the problem statements that you're working with is job change probability and the bank customer targeting data. We have done some business understanding of it. There are three other problem statements which we will continue to do. But first, let's go ahead and implement this. And the learning method that we're using is linear method. So we'll continue to revisit some of these things continuously. So that being said, let's get started now with importing the data, both of these, and then doing some EDA on top of it. So let me go back to this location. That is my data dictionary. So we've like sort of captured the variable names for both of these problem statements. And so today we are going to see what more we can capture from this and get to know these features, right? And that is the data understanding part of it. So I've opened up my Jupyter Lab here. So the tool that I'm going to be using is Anaconda. It's going to be looking something like this, where this Jupyter Lab, I'm going to use this. It's going to be helpful for visualizing everything and just keeping it organized. And this is sort of going to help you scale up all of the problem statements that you're going to be using. Okay. So yeah, that's pretty much what we're going to be using. And so let us go into the first problem statement. So the directory, remember guys, I'm in my documents directory, and then I have a folder where I have said it's called data science practice, and under that problem statements, and under that all of my problem statements are present, and I'm on the same folder in Jupyter Lab here. So I'm going to go into one of them. There's my input and output data, and I'm going to create a new notebook here. So I'm going to say Python 3 notebook. And it's going to create it here. I'm going to rename this to, let's say, step 1, import and basic EDA. Okay, so that's the first step that we're going to do. And let's give it a title also, import and basic EDA. So in case you want to get a markdown, you can just do like control escape 1, 2, or 3 to get a title which is in markdown. Okay, I'm going to do 1, the main title, run it, and then I'm going to call this, I'm just going to put it as 1/. Now first of all, we will require libraries. So I'm going to say import libraries. I'm going to expand this a little bit so that it's a lot more visible. I'm going to shift myself a little bit towards the bottom side. Yeah, that's much better. So we have a lot of space. Yeah, so we're going to import the libraries now. I'm going to say import pandas as pd. We'll also require numpy, so numpy as np. And that's the two libraries we're going to import. Okay, cool. So they're imported. Now within the input data set, we have test and train. So we need to import both of them to start stuff. Okay, so I'm going to import train and test. Escape and above, I'm going to add a cell here and I'm going to say import train and test data. So this is going to be pd.read.csv, read underscore csv, and I'm going to get this guy's location here, right? So let's say copy path. I'm going to paste it here. So that's the big path, but I just want it till this input statement. Okay, so I just go back and then something like this should be doing it. Copy it and paste it here. Okay. Okay, seems like this is good. I have train and test data. Let me just import it. Okay, that's going to give me an error, and errors are part of learning. No such directory. So I should be going into the input directory from this point onwards. I don't require this. Maybe this should be enough. Yeah, so that is good enough. Now I have the train data. So I go into input folder and get the train and then test data correctly. So if I run this, I should have both the data sets now. So train.info, let's do train.info and just check it. This is good enough. I'm going to check data sets. Okay, so we have this train data, and similarly I can do the test data set also. Okay, so we have the enrollee ID, city, and all of the 13 and the rest of the variables here. 11 variables, 12, 13 variables plus the target. So that's a 14 variables, 13 variables per target. And then here we have just 13 variables and no target. So this is our work is to predict the target here. Okay, so we're going to be working on that. Okay. Cool. So we imported the data set, and again, this is pretty simple to do this stuff. If this is good enough, and we are able to look at this data nicely, what we can do is take the same code and use it in the second problem statement and see how that works out, right? So I'm just going to go back to this one here. You see this is already created, so I'm going to go back and do the same thing for this place. I will go here and this code is again open, right? So this is for the second problem statement. I'm just going to again run it, read both of this train and test data set, for the info. You see in this particular thing, we have, in this problem statement, we have 17 features along with one target. And similarly, let's look at this one. We have 18 features with Y. Okay, that's train and test, train and test. "17 features here, and in the test there are 18 features. For some reason there is this index that is available here, which is extra. We'll have to see what that feature is. Anyways, now we have two different imports set up. Now we can begin we know these features, the names of these features, and somehow, if it'll be good if we can capture some of this information and then place it back here. And the way that is, it's interesting to see how he's able to identify the same things within Python. And this is basically getting the information, just the column, count, and data type, and similarly this one. And to know more about the features, we will do a describe, which will give which will give you some descriptive statistics like beat, median, mode, maximum, minimum, and all of that, right? Just to know what's happening in the background, right? And so to do that, we will do for the first problem, let's just do it. We'll say train.describe and it gave us all of the summary statistics for this particular data. But we also want to sort of get summary statistics for the categorical features within this, just to know what we have. So I'm going to go to pandas describe library and see what else it's there within this particular method, right? So describe is what we are looking at, and this is the describe function. Let's see how he has used it. Yeah, we've used it accordingly, dot describe somewhere here. Date time is numeric. Date time is numeric is true. We don't have any of these date time features. We do have some categorical, numerical, and object features. So we have all of this. Yeah, so here you can see that, if you use a describe function, it only gives you the numerics summary statistics. And if you want to include rest of the features, that is the categorical, numeric, and object, then we need to say include all within it, right? So I'm going to say include all to give me all of the rest of the features that are available here, right? And let's look at some of the features here. Enrollee ID is not going to make much sense here, but let's look at city, right? City is a categorical feature, and that is why you'll see NaN for frequency, mean, standard deviation, minimum, all of that. And basically in city, you'll have 18359 records, unique values 123, and top is like city 103, frequency is 3458. So these are some of the statistics that are available for a categorical feature. For numerical features, all of these will be available, and these three things will not be available for numericals. So this is something that is interesting to look at, and this will guide us to transform the features in ways that is going to help for the modeling purpose, right? And remember, we have to classify the data, and so we'll have to treat numerical variables and categorical variables differently before we can model it, right? Similarly, let's just take train and describe it here, and it's going to again give us this information, right? But it's interesting to see how we can replicate or sort of get this kind of information within Excel itself and see how it's going to be helpful for us. So what I'm going to do is, for this particular session, I'm going to sort of go through go through and explore the features that are available on Excel and see if I can replicate this results, right? Just for practice sake. So I'm going to open the trained data. Okay, and I'm going to save this as, okay, the first problem statements, trained data. Okay, so I've saved this as Excel, and let's see if I can explore some data within it. Okay, so I have this trained data. So what I'm going to do now is, let me just expand this a little bit, and the objective here is to really understand what's happening in the background of this train.describe. And it sort of is a memory muscle, practice muscle for us to sort of get this kind of information within Excel itself and know what's really happening, right? So we have this training hours and the target and so many different answer development indications which are numeric. The rest of them are categorical. And let's see if we can sort of get all of these values that are available here within Excel itself. Okay, what is possible, what's not possible, let's not think about it. But what I'm going to do now is take this and take just like 5 rows, take it here, and I'm going to say paste the special values and transpose it. Okay, there are shortcuts to do that, but yeah, let me just expand this also. So as you can see now, I have all the column names. So I'm going to insert a column here. This is a feature name, and these are like the first 5 values. So I'm going to say value 1 to 5 that are available here, and I'm going to insert few more columns here just to give us some information. So we need to get like the max, minimum, unique count and all of that. So for that, first of all, we need to figure out whether it's a numeric or not numeric, right? So for that, I'm going to just take the first value that is available here and check if that is a numeric or no, and it's going to be giving us that feature, right? So I'm going to say data type, and is equal to if the first value that we have, right, this first value, we could say is numeric, is number. This first value is number. Then we're going to say this is numeric, else categorical or object, we'll say, like we have it there in Python. Okay, so numeric or so yeah, it's basically integer, object, and integer, right? So all of these floats and integers, these are numeric for us, and object is just objects, right? So I'm just going to call this as D type. Okay, so if I do this, I'm now getting a replica of what is present within this, right? So let's just close this a little bit, expand this. Yeah, so you see, we are getting this numeric, object, numeric, and then again, most of them are object. Experience somehow seems to be numeric here, object here, and for us it is numeric. It might be because there might be something greater than or something like that. So we have this sort of a value which is available. That is why it's sort of making it non-numeric. Anyway, so this one is again an object, so we're going to put something like greater than 10 to ensure that that is an also object. Now we have a rest of them as numeric. Target is numeric. Last new job is object here. Similarly, we have something like greater than 4. Again, I'm just replacing the values, but it'll sort of help us get to the closer part of it. Anyway, so if any one of the values is object, it treats as an object, and so we are able to replicate this part of it. Okay. Now, for anybody, for all of those features that are numeric, we want to get the what we say, the summary statistics of it. Okay, and so that is the next part. That is this here. If I had to just do it, just copy this, do it without this, you will get all the numeric features that are available here. So these ones, right? I can place this here. So I want to get the summary statistics, the count, mean, standard deviation, all of that. So for that, I'm going to say, first introduce. Yeah, let's take this here. It's going to be much more easier to. Yeah. Okay. So we want count and mean first. Okay, so count, mean, standard deviation, and then we have minimum, max, min. These are the quartiles. So Q 25%, and we're going to say 50% and 75%. So these are summary statistics. Okay, this is min and then it's max. So these are the summary statistics we want to get from this data. So we're going to reference these columns often. What I'm going to do is I'm going to create them as a named manager, so it's easy for us to do calculations on top of it. So I can just go to this create from selection here, say top row, and basically all of these named ranges should be created. Okay, so if they're created, I'm good to go here. I can simply say now count A indirect of this, close the bracket, and I should get the count of it. And if I do this, this is how I'll be getting the count of the values within that feature. And let's see if I'm able to replicate some of the details there. So I have 18359, 18359, 18359, all of that. You see 18359, but some of the values have first, yeah, let's just filter it for the numeric features. Yeah, for numeric features, all of them have some values, and we are able to get that, right? Good. So that is good. I think it will be good to just have all the numeric features in one place. Cut and paste it here. So all the numeric features are in one place, and let's see what else we can do. Yeah, so this is so far working good, which means there are some missing values here, right? So we'll deal with them, but first let's take care of this numeric feature that we have. So mean is going to be average within here. So average indirect of this, close the bracket, and you get the average. I copy it down and then look at the averages that this particular data has. So average is 16729.36, which we got it, 0.84, 65.89, 0.13, we got that. which means we are in the right direction. We can say standard deviation of the population indirect of this. Am I close to it? Yeah, 9643. Yes, several functions, so it's easy to go wrong. 1160 and 0.93. Yes, I'm getting those results. Okay, this is good. Max of indirect of this, close the bracket, copy this. I'm going to replace it here. That is going to be the minimum of it. Okay, so that is there. So max and min are looking good in our case. So let's just check. Oops, my bad. Max and min, max and min. Yeah, max and min are looking good. So minimum. First, let's check out minimum. Yeah, for so this is minimum. Actually, this should be minimum. That should be maximum. So 1.44810, which is good. Maximum again 33080, 0.9436 and 1. So looks like we have the details that we require in terms of this, and now we want to see if we can replicate the same result for the categorical, that is the n unique top. We've got some of the values from there, right? And then we want to get like frequency. I don't think so we can get frequency. But yeah, let's try. We have how many unique values we need, right? So let's see if we can get that also. Yeah, for that, but we need this also. So here I'm going to say quartile of indirect of this, comma 25th. Okay, and let's see if at all we are able to get the right quartiles for it. 25th is 8378.5, 0.76, 23, and this. So yeah, this function should be good enough. Could copy it and get the 50th percentile. That is also there. Similarly, again, this one I'm going to go and say the third quartile. So all of this is gotten. We have these values, which is close to what we have within it, right? So that's how this descriptive statistics is really coming, and either on Python or Excel, you should be able to ideally replicate what you have done there, right? Now we need like a n unique and top and frequency for the categorical features. Mean, median, mode, this all is going to be NaN, right? It's not going to be available. That's how it's available, right? It's there, right? It's not available. So I'm going to do that. Even if I try to do it, let me just even if I just try to do it for one, right, I'm not going to get anything from it. So yeah, it's going to just give us error. which is why we will not try to even do that. Now we can try to get n unique for the categorical features. Right? So for these, we are not going to get any of this. Top, we've already got some of the values here, so we're not going to get that. And let's see if we can get frequency. I don't know what that frequency is, but we'll try to see what that is. Okay. For city, number of unique values. Let's see if there is unique values from, let's see if we want to get unique values from here. Yeah, it gets the unique values, but we don't want like that. We want the count of unique values. So the idea here is to, let's just try to replicate it. The city, yeah. So let's see here. I'm going to take, yeah, let's just take city, for example, right? We want the unique values from the city variable. So the city feature would have city 1, city 2, and city 3 spread like this. Okay. And so if I just get like, you know, the count A of this, count A is basically giving how many values are there within that feature. So if I get that count A, I get 10 here, right? But ideally what we want to do is get the unique values from this, right? So the unique values would be something like this. We go here, go to home, data, remove the duplicates. And that's the 3 that we want to get, right? So this is what we want to get. And so the way we can try to get it is using the unique function, right? So we can say unique of this particular array. Let's see, it gives us the unique values, but we don't want just the unique values. We want like a count A of these unique values. Let's see if I'm getting it. Yes, I am getting the count A of this unique value. So we're going to use this here within this sheet. We'll call this summary to get that information. So it's going to be like, you know, count A of unique values. I'm going to say indirect of city. That's just a way to get and do, you know, apply the same function on multiple columns and close the bracket. So we'll do that and we'll calculate most of them. So seems like we're getting like one extra value. I think primarily because the column name is included within it or what. So just seeing the name manager, city. Oh no, it should be 123 itself. Yeah, 123 it is, and I have 124. I have like a +1 for gender 3, for relevant experience 2. I have like one extra category for each of them. So let's see what's happening there. City, copy it, paste it here, data, remove duplicates. Okay, 124 unique values. And yeah, there is 123 values here, including the city name. It's 124. So I think what we can safely do is just say -1 on this, and I should be getting the unique values of each of these features. Right, so that's how this occurs. So yeah, we're able to get this. That is the unique values within it, which is good to know. And this is called the cardinality of a feature. And so the way we treat city is going to be different from maybe others. Like this is one's categories and this is maybe some other category. So we're going to deal with this differently, and then these are like high cardinality, so we're going to deal with them a little differently. Okay, so yeah, frequency is something I don't know what happens with that frequency here. 4358 12884. Okay, let's just Google it. What is frequency in describe? Yeah, that is something everybody's asking. This frequency. Frequency. The top is most common value. The frequency is the most values frequency times most common values frequency. Okay. I think we should get that top value here. So what it's doing is it's getting the top value which occurs most number of times and taking frequency of that, which is good to know. What's the top value? Let's see of each of this city and all of that. So for that, we're going to do pivot table. Should we do pivot table? Yeah, let's just do pivot table so that we can show you for now, and then we'll think of how we can automate that. Pivot. Okay, so let's take the pivot. We're going to take city and we're going to take count of city. Sort it by descending order. And there you have it, right? So the top value is city 103 in this case. And then we want to get the count of this particular thing, right? So if I do just lay count if, right, indirect of city, comma, this particular value, range and criteria, city should be giving me this range. Okay, let's see if this one is working on no count ifs. Is should I reverse this? Count ifs, let's say. Okay, something is wrong, so I can say indirect is equal to count ifs of city, comma, this particular value. Yeah, it's coming. Of that value. So yeah, I can just simply give, no need to give indirect or something. I can simply give this. Yeah, that is there. Right, so if I just copy this down and get the unique, the most frequently occurring value, we'll be able to get and replicate that particular result that we get in a describe function. And so it's good to know how these numbers came in. And so this is a classic example of non-linear learning. What you see is like whatever you see in Python, you typically want to replicate that within Excel, and so it gives you good practice to how that number came across and we figured it out, right? So this, you saw me how I figured this out, and so let's see quickly how we can get that. We should be writing a code to get all of the unique values, but for now I'm just going to like skim through it and get all of these values. Okay. That's male. That is the most common here. If you know a better way, do let me know. Okay, that is okay. I'm going to take indirect here of this particular feature, so that this can be replicated. Yes. Earlier I was doing it wrong, but now, yeah, this is the correct way of doing it. Yeah. Hey Bhargava, I'm good. I'm good. Okay, cool. So like that, male relevant experience, if you can just push through all of those values, we will be able to get it. Right, so I'm going to take these values. Relevant experience. This one is this. This one is the top value for this. Okay. And then I'm going to take this out. I'm going to take enrolled university. No enrollment, the top value. Again, I'm going to remove this education level. Go to education level. Graduate. This is the most commonly occurring one. And then major discipline. STEM. Similarly, experience. Look at this, we have to sort it. Greater than 20 is the most commonly occurring one. Remove experience, say company size. Blank we can skip and just take the next value. Company type. Take this value and put it here. And remove company type. Last new job is another one. Sort it. Okay, so one is the most occurring one. Okay, so these are the most common values that come in. Oh, I think company size and type, I might have got the numbers here. Let me just go back. Company size. Yeah, this is the, this one is the thing, and then the last company type. Private limited. These are the top values. Let's go back here and I'm going to paste it here. And it's going to give me the unique values for each of these values. So for today, we were able to now explore the summary statistics of all the features that we had here. So roughly what we did is we imported the data and we were able to get the summary statistics using describe. We started by importing the libraries, and then we imported the both train and test data sets. We checked the column names and data type using info, and then we did a describe. The default describe only gives numerical variables summary statistics. So we said include all to give the rest of the features, and this table we replicated on Excel, and this is what it looks like. So I'm just going to save my work, and now you know how the summary statistics looks like in Python and how we can replicate it on Excel, right? So as you can see, a lot of learnings in terms of you trying to replicate the results here, and definitely going to be very helpful for what you do. Okay, so far, according to Chris DM method, we are in the data understanding phase. Collected the initial data, we described the data. We want to explore the data where, data quality, missing value treatment, and all of that thing, right? So within the data understanding, we acquire the necessary data and if necessary load it to get an analysis tool. We import it and then we describe the data, like number of records, field identities, and all of that, right? So we are able to do these two steps in this particular session, and then we still have another session where we need to visualize and see all of the features to help us identify quality of data and all of that, right? So first we'll verify the quality of data and then explore the data. We'll treat missing values if we have to do, and then we'll do the next steps. Okay, so seems like this is what we will do for today. Enough for today's practice session. So again, your task is now to try to whatever I did on this particular problem statement, right? You can try to replicate it on this. We've performed this on Excel, and so this next step you can try to do it on Excel, and then again try if you are done with these two, then move ahead and do this. Okay, so that's all for this particular session, guys. This particular I typically come online on Tuesdays or Thursdays, 11 a.m. Or 2 p.m. to 3 p.m. and so connect with me on this particular thing on these sessions. Also, I've put a link in the description section. You can join my community there, and we'll go live on different other things, not just this practice session. There'll be job search and all of that other things going to go that I'm going to also conduct, right? So join in. I'm just building the momentum, and awesome to get started. Thank you for joining in.